Hi again. This video is about reflections in curved mirrors. So we've done a previous video on plane mirrors, which are the flat mirrors that you normally look at your reflection in. Curved mirrors, it's the same rules, but it has different effects. So first of all, you need to know the terms concave and convex. So think of concave like a cave, like it's when it's on the sort of inner curve of the mirror, and then convex is when it's the curving outwards towards you. So that's concave, like a cave, and convex. So when light is coming towards a plane mirror, flat mirror, remember we had our law of reflection, which means that here's the light ray going in with the arrow going in towards the mirror, and then we drew our imaginary line of normal, which is at 90 degrees to the mirror, and then the light ray would bounce back off the reflected ray, would be coming off at the same angle as the angle made with the incident ray. So the angle of incidence is exactly the same as the angle of reflection when we draw an imaginary line called the normal at 90 degrees. Okay, the same thing applies with curved mirrors. So here I've drawn a great big concave mirror because the light ray is going into the cave-like side. I've just drawn 3 light rays, but light rays could come in at anywhere along here. So light rays coming in, you do your imaginary normal line at 90 degrees to the mirror. So depending where the light ray is coming in the mirror, the normal is going to change. So in the middle of the mirror, the normal will be exactly the same as the light ray. So the ray bouncing back out would be straight back out again. Come round a bit, the normal would be there, there, there. And because the normal changes because of the angle of the light, so too does how the rays get reflected. So if this is our normal at 90 degrees to the curve of the mirror at that point, angle of incidence, then you get the angle of reflection. So those two would be the same. So instead of the light ray coming sort of straight back out of the mirror again, it's going to come back out at an angle like this. So if I move to my next page, we can see that if you drew all the reflected rays coming back out up here, here's the ones going in. This one here is going to reflect back in that way. This top one will go back in that way, and the one in the middle will come straight back out again. And so that's what we call converging light rays. So because of the curve of the mirror and the change in the position of the normal, the reflection brings the light rays back towards the middle. So converging is going toward, they're all coming together towards the middle. That's what converging means, and that's what a concave mirror will do to light. Where they cross over, the light rays, that's the focal point. So that's where you see the image. So if we look, move my fingers, if we look further down here now, sorry about this, a bit tricky. Okay, so with a concave mirror that converges the light rays, what happens is our eyes still think that the image is coming from wherever those reflected rays came from. So we think it's coming from way over here, just like when we did the mirror story, okay? So what happens is we see a big version of something that's quite little. So this is very useful in real life, and when dentists use those little round mirrors to look at your teeth, they see a really big version of your teeth, or if you're looking looking at yourself in a makeup mirror, you can see an enlarged version of things because it's doing this. The opposite happens with a convex mirror. It's the same rules. So here's a big convex mirror this time. Sorry, you can see that. And then, so we have our rays of light going into the outy curve here. Again, you would just use your normal. The normal will again curve as you go around. So if the light rays are there, you just figure out that 90 degrees is like that. So there's a light ray going in, angle of incidence equals angle of reflection, and so your light ray is going to bounce off out sideways this time. Or if you're down here, it'll bounce out that way. So now the light rays are diverging. They're getting further apart in a convex mirror. It makes them spread out rather than go in. You can, if you like, think of concave, the cave meaning the light, you know, it's a curve like this, they want to go into the middle like that, and convex, because it's an outy curve, the light rays want to go out. But if you do your line of normal and draw them, it should work out that they diverge in a convex mirror. So in a convex mirror, what happens because of the light rays diverging is we see a smaller version of things, but we see a wide view. So we see lots of things, but they're all small. Whereas in the concave mirror, we saw a small thing got made bigger. So if we're seeing lots of things in a wide view because of this, around here, it's good to get a view of lots of things at once. So that's why it's used in security mirrors in shops, or the mirrors you see on roads to see around corners, like the one at the end of the Owens Road, car park driveway, and in car rear view wing mirrors will do the same thing. So you can sort of think of it like, if you think of where the reflected rays are, if they're out wide, you're going to see a wide view, and if the reflected rays are going in, you're going to see a small view. And then our line where our eyes think the light has come from shows you the size of what you'd actually see. So you'd see a small thing big in a concave mirror, and you'd see a really wide view but small bits in a convex mirror. I know that's hard, so I've done one more little image for you where I've tried to draw it. My lovely drawing. So here we are, concave mirror. The reflected rays are going to converge, so you see a little thing like your eye looks really big, like when you look in your makeup mirror, and then a convex mirror, the light rays are going to diverge, so you get a really wide view, but you see small things. So this is like people in a shop, and here's the security mirror at the top. The mirror will show all sorts of things right around the shop from one side to the other, but each individual thing will look smaller than it is in real life. I hope that helps a bit. I know it's tricky. Just remember, it's still the laws of reflection, but the angle that they're reflected at changes, and know the terms converging and diverging. I will explain things again when we get back to school. Okay, bye for now.